So here on page 258, specifically, even notice the headline, it's a horizontal system in circular motion. So it's, remember, we're just on a horizontal surface going around and around, or something is just staying at the same horizontal height. So talking about a car moving around a bend. So it explains how the centripetal force we need to set equal to FF. So that's exactly what this question is about. It's about a car going around a curve and giving us the data, and then asking us about coefficient of friction between car and the road so it doesn't skid. So let's draw a free body diagram for this. So we'll just have our car as just a box like we usually do. We have our Fn and our Fg. They're going to equal each other, just like we did at the beginning of all of our dynamic stuff. And we have our FF. Now, when it's skidding around, we're assuming that there's not going to be an applied force anymore. It's skidding around. So it's kind of like, here's the D of M going around the curve. Now, since it's a horizontal system, we know that Fn is equal to Fg because it's not floating up or down. Yeah. Pardon me, sorry? I can't hear you. Oh, yeah, but it's FF is pulling it into like the middle. Like we're saying FF is equal to FC. So I see your question. No, but I don't know why. Like if you look at the diagram here, it has FF going towards the center because we set that equal to FC. But I might think about your question a little bit more too and let you know. But for this example, I know that FF does go towards the center because it's equal to FC. Okay, so that's kind of what we have to start with. Let's just make a note to ourselves so that if we're studying, we can remember. FF is equal to FC because FF keeps the car on the road as it goes around the corner and overcomes inertia. Because the car wants to keep going straight, the direction that it was going. So to overcome that inertia, it needs the force of friction to keep it on the road. So now let's do the math part about it. So we have our mass is equal to 925 kilograms. Our V is 25 meters per second. And if the radius of the curve is, so good, our radius is 72 meters. And we're trying to find mu. So we know in order to find mu, we need the formula FF is equal to mu Fn. So I'm going to find these out both separately. So my FF, I can say FF is equal to FC. And my FC is equal to M times AC. And then I look and see, well, which AC formula is appropriate for this, for what data I've been given. So we can look and see FC is equal to M times V squared over R. So FC is equal to 925 kilograms multiplied by 25 meters per second, and that value needs to be squared. The 25 is squared, and 72 meters. So if you notice, I write my 25 meters per second and then put that in brackets and then go squared, because I don't want to mix up going meters per second squared, because that would be acceleration. So I keep my value and the units in the brackets, just so I stay organized. So then I can say my FC is equal to 8,029.5 newtons. So because I said FF is equal to FC, so now I can say FF is equal to 8,029.5 newtons. Well, now I need to find my Fn. As we said before from our free body diagram, we know that Fn must equal Fg because there's no up or down movement going on. So that's equal to m times g. So 925 kilograms multiplied by 9.81 meters per second squared is equal to 9,074.25 newtons. So now you can find your mu. So mu is equal to FF divided by Fn. So mu is equal to 8,029.5 newtons divided by 9,074.25 newtons. So mu is equal to 0.885. Sorry. Okay, so now I would first like you to finish your lab and you can do question 5 now using this force, centripetal force formula. And then I'd like you to do the practice problems, and there are textbook practice problems at the end there as well. I do have answer keys available that if you get stuck you can look at them. Oh, and for number 3, it looks like a multiple choice question, but there may be more than one correct answer. So for number 3, circle any and all that are true. You'll see what I mean when you get there. But yep.
Is 4. What's the force acting of centripetal force? Is that FT?
Oh, for here? Yeah. So for number 4 on your lab, yeah, FT. Is what you would find, and FT is equal to FC. So then for number 5, use your FC formula.